Hello and welcome to this session on overview of big data analytics. Kapil Oberai, I'm a faculty in the geoinformatics department at IIRS. In this session, we'll try to understand the overview of the big data, and we'll start with seeing the brief history of the data, how it has evolved. So to call as data to so-called big data. And finally, we will also discuss on the formal definition of big data and also the characteristics which is generally defined using NVs. We'll also try to understand the various types of data uh, like structured, semi-structured and unstructured. Then moving forward, we'll get into and understand how does this big data concept is being used in the geospatial domain, and we'll understand the concept as well as the challenges, followed by seeing a bit on the what are the various tools or frameworks that are available. So we'll discuss on the Hadoop and the Spark framework. And then finally, we'll talk about cloud computing and how it is related to the big data. So let's try to first understand the data and how it has evolved over a period of time. So data initially begin moving from the file cabinets or a paper-based to a digital with the coming of the personal computer somewhere in mid-1970. But what led to a huge change in the way we store, process the data and also share the data is when the internet people started use connected to the internet and started sharing the data. Then it leads to the real exploration in the amount of available data in the world. So from moving from a paper-based thing to the digital with the coming of the PCs, followed by availability of the internet, which enable data sharing across the world, and also enablement for the access and also the contribution of data from the people. This is a simple infographic here, just to highlight that in 2005 and from 2000 and followed by in 2014, the storage has increased 1,000-fold. So 128 MB to 128 GB. And also the hardware cost has also come down, which is also one of the factors wherein people have also started to collect and store the data. So followed by the internet, somewhere in the early 2000s, there was a rapid advance in the computing and the technologies such as storages. So the portable hard disk devices also start coming, where users were collecting and storing the data. And also, as we talk about the internet, added the impetus in this drive by providing a platform as a dissemination platform wherein the exchange of information can be done at a global scale. So now we say that the world is a global village. So one person sitting at one remote corner of the world can talk and maybe exchange the information across the globe. Now, what further leads to this shift was coming of new tools and new mechanisms like social media, where the people are also contributing the data and also provide a mechanism for people to share their views. Now, the availability of the smartphone, also the reduction in the cost of the smartphones with the penetration of the internet at the grassroots level, that is the broadband connection, and also the participation of users. We discussed in my previous lecture on the citizen science part. It enables the people to work as sensors on the ground and can assist in the various governance or other social projects. So people from pure, let's say the users of the internet also start contributing data and also adding value to the data sets. It will be fair to say that maybe we are in a data deluge era. We are somewhere drowning in the sea of data. So this is the infographic from Domo, talks about data never sleep. So here you can see the number. This is on of 2019 year, but you can see how many YouTube posts are being done, how many emails are being transferred, how many posts are being done, how many taxi rides have been done in Uber and so on. But the important thing here is that Now, most of the businesses are making their decision on the data driven. So the data is very, very important. And now with the huge availability of data at our end, how best to we can make use of this data and assess the ultimately the decision making so that the business can grow and the potential could be generated. It's very, very crucial now. And just to put these numbers in perspective, so let's see the numbers. So we are aware that bit is 0 and 1, nibble are 4 bits, byte is 8 bits, and we move across to the level. So kilobyte 1024 bytes, then MB is 1024 KBs, all the way from gigabytes to terabytes, and nowadays we're talking about the zettabytes. Just to tell about zettabytes, it is 10 raised to the power 21. Right, so you can imagine the number of zeros we are talking about. It's a huge number or huge kind of a data sets that we are nowadays talking about. So earlier we used to restrict on the terabytes. Now there's a huge amount of data is being generated, both in the geospatial and other areas, which are very, very useful. This is a report which talks about that the global data sphere will grow from 33 zettabytes somewhere in 2018 and up to from by 2025 we are talking about number like 175 zettabytes. So you can see from this graph below how the amount of data has been increased over the period of time. So 2010 to 2025, you can see how much is the amount of data is being generated. And another way of viewing this is that data is the new oil, as someone rightly said. So there is a quote by Michael Palmer saying the data is just like a crude. It is valuable, but if unrefined, it cannot be really be used. It has to be refined in order to get some profitable activity. So the data must be broken down and analyze it for to have the value. So since most of the businesses are making a data-driven decision, so the data that is being captured from various sources has to be analyzed in the least possible time, so that that data is useful, not a old stale data on which we are basing our decisions, because some decisions will require the handling or analyzing of the real-time data. Some may be on the historical data, but so the both has now taken into consideration so that the business could be served in a better way. Because the timeline nowadays for to come up with the service or maybe resolution is not, we are not talking about month or days. Now we are talking about minutes and hours also. So having talked about data, what leads to the generation of the proliferation of the data, now let's also formally define what we mean by the big data. Now we are here, we are not purely talking in terms of the volume or the size perspective, but later you'll appreciate what kind of issues when we talk about such terms like big data. So big data is basically defined as the huge collection of various data sets which are difficult to process by using the traditional data processing platforms or current state-of-art approaches for data processing. Which means the traditional way of data processing based on our relation RDBMS systems may not be able to handle such kind of a diverse and the voluminous data sets. Another definition is collection of data sets that is large and complex, that is difficult to process using on-hand database tools for traditional data processing applications. So the traditional way of batch type of task may not be suitable. Traditional mechanism of storing our data in a RDBMS kind of a system which have limitation of scalability, serving n number of users will not be the way ahead if we want to use such kind of a data set. So obviously here we are talking about diverse data sets which becomes difficult to store and process using a traditional mechanism. So which means now we need to move from a standalone kind of a system to a distributed environment where the work would be divided among the nodes, and the task could be done in a easier manner and also in the less time. So the traditional mechanism of first downloading data, collecting data, processing them will not be able to serve our needs. Now, in the literature, you will come across this big data characteristics where they use different V's to denote the characterize the big data. So initially started with 3 V's. We talk about volume, which basically means we are talking about the size, the velocity, which is the speed at which the data is being generated, and third is the variety, which talks about the different types of data. It could be structured, unstructured, or semi-structured. So we are used to understanding the data from, let's say, structured data in the form of a relation structure. But how are we going to store and process, let's say, the geotag tweets, which may not be able to fit into our schema? Hence is the concept of schema on read and schema on write. Subsequently, more V's were added to characterize the big data. So apart from volume, velocity, variety, one more term V was added called as the veracity. This talks about the uncertainty in the data. There is also characteristics defined by 5V, where we have added the value to the existing 4 V's, which is volume, velocity, variety, and veracity. So the ultimate aim is what is the value that a business can collect after making use of such data sets. So looking at this figure here, you can see that talking from the 3 V's perspective, so big data, we're not only talking about the pure volume ranging from terabytes to zettabytes, but also the speed at which the data is being generated. As I talked about, we are no longer working on a batch kind of environment. We want to analyze and process the data as it is happening. And also, the type of the data is varying in the sense that the data that is confined to a fixed structure may not be completely relevant when we talk about big data, because there are other kinds of data types that are being generated, like semi-structured or the unstructured data. So again, from the big data perspective, we are not only talking from the volume, but also the variety and the speed at which the data is being generated. And since in the definition we talk about traditional technology, so you'll remember that the relational system are primarily required the structure or schema to be in place. And it is very difficult to store, let's say, the other kinds of data like unstructured or semi-structured in that system. Now let's try to understand these terms: structured, semi-structured, and unstructured. So the term structured, as the name implies, means that the data has a defined schema or structure attached to it. So that could be your CSV files, where the fields are separated by comma or some special characters like semicolon or space. Now, if we just understand from the pure database perspective, we can say that the data should be representable using a schema. Like if we follow a relational model, the data will be organized into rows and column, or a relation where the rows are called as the tuples and the columns are called as the attributes. Now, the other type data is the unstructured data. So again, it consists of any data sets that does not have a predefined schema so that we can fit into our relational model that we are used to. So for example, from the social media, again, example, if there is a post from Twitter, or let's say a post from Facebook, which also can have a geotag thing, will be an example of an unstructured data, because it's very difficult to put them into different kind of things. And also within the message also, there will be different kinds of information that will be present. So the point is very difficult to take that data and try to somehow fix into the very well-defined schema, which wherein this relation model really excels. The third type is a semi-structured, which is in between the structured and the unstructured, and refer to the data that has both the elements that of schema as well as some part of arbitrary. A good example will be your personal phone diary, where we could have columns for name, address, phone number, but notes can be considered as semi-structured because we could scribble different things and write in different manner, and will difficult to somehow make sense of because we can write multiple lines, we can put some figures and put some chart or figure, whatever we want to convey the message. There could be a kind of free flow running text, but could be a mix of images, text, and some other things that we can put under the notes section. Now in computing, we'll come across a term called JSON, which is stand for JavaScript Object Notation, which is an example of a semi-structured data type format that has both the structured as well as the schemaless or arbitrary things. And primarily it uses the key value pairs to represent the information. Now to understand in semi-structure, we can again take an example of email messages, which have both a structured part. For example, we know that every email will have a from address or the sender who is sending, the time when the message was sent. It will be common to all the messages, but what is different will be your body, the content, because again, various things could be put into this. It could be images, photographs, text, table could all be put. So some parts are very well defined because we know that if you're putting in a table, we know that this column will always contain that information. But if we have unstructured portion, then it's very difficult to identify what that content is that we want to refer. And then now you will appreciate that these kind of data sets will be very difficult to somehow put into a well-defined schema that we use to in our database models. Now, coming to the big data analytics, there are various kind of analytics can be defined as from text to audio to video to social media to predict. So let's see them one by one. So text analytics, we mean to process or extract the information by analyzing the unstructured text. So it could be extracting information from the blogs, survey responses, and also our social media. The next is our audio analytics, wherein, as the name suggests, we are trying to refer or inference or analyze or extract information from our unstructured audio data. And then possible use case will be in the maybe the call centers and also somewhere in the healthcare companies also. Now, video analytics is a very, very useful area wherein people are trying to analyze and extract the information from the video streams, primarily in the video surveillance areas. Now, this social media analytics has really gained a lot of momentum and people are using it because it also provides a good valuable information from the people on the ground. And then there are various platforms like Facebook, Twitter, and others where people are contributing the data and also providing their opinions. And this become very, very useful. Let's say, especially if somebody is looking for what is the opinion of a particular thing, of a product of a particular company. So that becomes a good viable source of data sets that people are also looking into. And then there are other kind of use cases also. For example, people are also trying to see the social media posts regarding various events. For example, people post about the traffic and the weather and so on. So that also becomes useful to understand the trend and other things. So here we are primarily looking into the basically opinion understanding of whether people are telling based on their feeds, and then most of these social media platform also enables the user to provide that feed in the form of they can geotag that information that they are sharing. So that also can tell the people who want to study that phenomena, maybe traffic or weather, from which place that is let's say emulative. The next will be the predictive analytics, primarily involving predicting the future outcome based on the existing or the past data. Various kinds of algorithms like linear and logistic regressions could also use. But important is to see here in this figure where we talk about the big data typical process flow that is being followed. So we can categorize into two categories. One will be the data management part and other is the analytics part. So again, under the data management, it will start with acquisition and recording of the data, followed by extraction, cleaning, and annotation, which is very essential for every data, followed by integrating, aggregating, and representation of data for decision. Once our data is organized, data is cleaned, maybe represented, aggregated, integrated with other data sets. Next, we need to follow on the getting insight from the data, and then we use the modeling and analysis approaches along with interpretation of the result to check whether the model has been correctly applied and being used. So these are the two phases under the big data processes from data management, wherein we are looking for acquiring, storing, and cleaning, and also integrating the data fit for the analysis, followed by the actual analysis involving the series of analysis steps, also modeling, and finally the interpretation of the result for suitable to a particular need. Now, coming to the big data in the geospatial world. So geospatial big data, if you think for a while, you will understand and also will agree that it's always been a big data. We talk about the remote sensing, so different types of satellite, different types of resolution. So maybe, so the geospatial from the definition perspective will fit into the category of big data. We can also define it as the spatial data sets exceeding the capacity of the current computing system with the amount of data sets that is being generated, not only the traditional mechanism, but also now we have new types of data sets. So the suppose new platform like drones are also contributing the data, social media, the location-based services, the model generated data sets are also being generated based on the different scenarios, which again are very, very valuable products to be used and analyzed. So here I mentioned that in Google, around 25 petabytes of data are being generated per day. This is somewhere old, but you can see the numbers. And also important thing is most of is falling under the category of spatial temporal data. And also you can see that this the more and more people are nowadays connected from the mobile than from the desktop kind of environment. This is primarily due to the penetration of the internet, wherein and also the reduction in the cost of the smartphone and also the availability of the smartphone with most of the people. So more and more people are now accessing from the mobile devices. So mobile internet usage has increased, as you can see from this figure I mentioned here. Now, just to put into perspective, you'll see that the geospatial big data is very, very important in various kind of domains, especially related to societal opportunities. Here I'm mentioning about the Millennium Project, which is now replaced with the SDG goals. But the slide emphasized that initially the Millennium, there were 15 global challenges identified, and whatever you can see that is highlighted in the boxes is where the geospatial can benefit, or the geospatial has an important role to play. Right from sustainable development and climate change to clean water to population and resources to health issues. And we have seen that in the COVID times, a lot of use cases have come up, and also in peace and conflict, the crime, and also in the energy sector. So these are the very, very important areas wherein the geospatial plays a very, very important role. Now, talking about the sources of big data. So we understand the big data from the characteristics of these and how it relates it. What are the limitations of the traditional systems? Now, if we just talk about the various sources of data, so we are aware that we have the Earth observation or the remote sensing data, which is generating data sets in a huge number, depending on the different types of satellite sensors, maybe operated by various agencies across the globe, and also under various kind of resolutions, spatial, spectral, radiometric, and temporal resolutions. the new types of platforms which are also collecting data, but there are other kinds of sources also which are leading to this data deluge. Is the surveying and the mapping data. So as a part of project, a lot of surveying and mapping activities have been happening, generation of land use land cover maps, the different products that again, apart from the storage of the actual, let's say satellite data, these data products have also to be stored, organized and use it for the subsequent project. Another is the location-based data. The GPS and other devices are fitted onto on most of the devices. So reading of the traffic data and other kind of phenomena can also be maybe we can see using this location-based data. This social network is again one of the widely contributing to the big spatial data. There are various platforms we talk about Twitter, Facebook, and they allow the user to also maybe share the information in a geotagged manner. The another which is really revolutionizing is the IoT, so the Internet of Things devices. So when we say Internet of Things, so things can be any device that is connected to the internet, which is again can be geotagged and is providing a streams of data to the generating a huge amount of data. So apart from the pure satellite or the IIRS kind of a data sets, these are the other data sets that we are looking for. And another that is not that I mentioned briefly previously was your generation of different scenarios or products data. Maybe let's say as a part of the IPCC, a huge amount of data sets has been generated, which again needs to be analyzed. And so model generated data sets is another one more category of apart from the pure surveying and mapping data that is also there. Now to see this EO data in perspective, so I'm just putting a slide here which talks about how the yearly data volume is growing from the agency perspective, but again from the users who are working under this area where they want to analyze a phenomena or study area over a period of time. So how they can make or organize their data and collect and make sense of data is again very, very important. So you can see that here I'm mentioning about the Landsat series, the MODIS, the Sentinel-1, 2, and 3. So amount of data is reaching in 2019 again around 4 petabytes. So from the agency's perspective, again, is a huge kind of a opportunity and also a challenge to how they can organize to serve their customers. Again, from the customers or users, we can say that. And again, from the users who want to analyze this data, then what kind of resources they should have so that they can make best use of this data set. Because now data sets are of this series are almost free. One can download it, but again, how they can extract the meaningful information out of that. So this is where some of the frameworks come in. So I'm mentioning about the Hadoop and the Spark framework. So first, let's talk about the Hadoop. Now, Hadoop is a software framework under the open source, which allows storage and processing of the big data on a distributed or a cluster environment. Now, please make a note that there are two components when I talk about Hadoop. One is the HDFS, which stands for HDFS, so which stands for Hadoop Distributed File System. So H stands for Hadoop, D for distributed, F for file, and S for system. And second is the MapReduce. Now this HDFS, or Hadoop Distributed File System, runs on the cluster and also provides the high throughput when I talk about understanding of accessing of the data. Now what it does, it is a distributed file system, which means it divides the data among the various nodes of the cluster. So the large files may be broken down into chunks and may be stored under different nodes to provide the high throughput access. Another important characteristic is it can store both the structured as well as the unstructured data it can store. And it also provides the fault tolerance. What I mean by fault tolerance is, if you see on this figure here, so suppose there is a file called XYZ, which are broken into 3 blocks, A, B, C. So HDFS allows to each block to be stored at the multiple nodes. We can set the replication factor, but generally by default it is 3, but we can go for more on that. that is configurable. But important thing is that each block will be stored at different nodes. So we see here it is D1, D2, D3, and D4. So in case even the D1 goes down, still the data are available from the other nodes like D2 and D3, which means the failure of the node, which will happen in a commodity-based cluster or a distributed as per the CAP theorem, still the system will be up and running. So that provides a kind of fault tolerance in case of even the node goes down, and that could be handled. And also it is scalable in the sense that we could add any number of nodes at any moment of time. So there are two things in this Hadoop. One is the file system, which is a distributor, which allows high throughput, fault tolerance, and the second is your the programming paradigm, which allows you to process the data over this infrastructure, which is called as the map reduce paradigm. This we'll see in the next slide. Now, this map reduce is primarily the programming component that allows the large task to be broken down into smaller tasks and then maybe analyze at each node level where the data locality is being maintained. Now, in map reduce, you will see there are two terms. One is map, one is reduce. So this map reduce framework again divides the component into two phases. One is called the map, and other is called the reduce. So the map phase primarily divides the last task. So suppose there is a storage, the different nodes. So the last task is divided into smaller pieces. So it is like um, scattering the data across the node. Each node will do the little bit of part of the computation, and then that will be assembled or grouped together and shuffled in the reduce phase. Finally, we get an output. So instead of working on a standalone one node where the data and the whole process will happen at that node, we can distribute the task among the nodes. So the nodes carry out the portion of the task, wherein and later the task results could be can be reduced or maybe aggregated, and then the final result could be produced. So the map phase divides the task into smaller pieces and then gives them to the each piece to the active nodes in the cluster. So there is also a concept of data nodes and master node here. The master node controls all the your data nodes. Second is the reduce phase, which collects the result from this map phase and process the result into the final result. And as I mentioned that this is because this it works on the HDFS, so even if the few nodes have failed, still the process can continue, and then we can expand the cluster at any moment of time. So this allows us to divide a bigger task into smaller tasks, which individual nodes can handle those tasks. And this is again a good way of representing the data locality, which means the individual map phases work on the individual data blocks that they are there in that node instead of, let's say, the way the data has to be pushed from one location to the other. So data locality again is a very, very important point when we talk about this Hadoop system. Because we have to remember that the passing of the IO time is always more than our processing time. Now, the another framework is called as a Spark. Now, one thing that is you can also understand here is this Hadoop was primarily created for a batch task. So, given a large task, can be broken down and maybe run as a batch mode. So that was the limitation. Other thing was whatever results were being generated were again returned to the disk and read from the disk. In that way, it was slower. It was not doing any in-memory process. So there is this is where this the second framework, which is called the Apache Spark, comes in, which provides an in-memory computing for processing a large-scale data. So it allows the computation to happen in the memory, not on the disk. It makes use of the structure called as a resilient distributed data set, or RDD for short. Nowadays, in version from 2 onwards, they're also making use of the data sets as a structure. But the important thing is this structure allows in-memory data store and can persist the stored data on the disk if we want to. But most of the storage and processing is done at the memory level. And we remember that the memory is always faster than the external storages. Now, compared to the Hadoop, The Spark is very faster, has a huge performance improvement because it eliminates the reading and writing to the disk. Because most of the processing is done will be in the memory itself. Another important thing is it provides some kind of lazy evaluation, which means the status of assigned computation resources to the computing task is maintained until the task is complete. And then this is completely different from Hadoop, where the resources has to be provisioned and called for and released when even the task is done. And this becomes very useful, especially in our from a spatial data analytics perspective, because there will not be one series of jobs, but there will be a chain or of multiple analysis that has to be done. Because in that way, Spark is superior to the Hadoop. And also in the spatial analysis, we need to go over the same process again and again, iteration, wherein the Hadoop was not suited for that kind of processes. Another thing is that this Spark is also being called as a unified system for data processing. Hadoop, we can also look at terms on the, we talk about the HDFS and the MapReduce, but it generally look in terms of the ecosystem. So we can add more tools as we go along. We want to have some, let's say, the newest system we can put along with that, along with some data analytics libraries and map, let's say machine learning libraries. But this come as a unified. So here, instead of installing and learning and then also integrating those external libraries to the existing thing, it supports the streaming, the machine learning, and graphic processing as a part of the system. So from the Spark core, we have the support for SQL, Spark SQL, along with support for stream, machine library, and also for the graphs process. So, and also another thing is it is ideal for the real-time analytics because most of these things are done in memory, not in the, let's say, from the storing and reading every time, even the intermediate results onto the disk. Another important thing is in Hadoop, we are restricted, let's say, to the Java language, but here it provides multiple programming language to be used. So we can use Python, R, Java, also, and other Scala kind of a languages are also possible. Okay, so let's also see the differences. Briefly, we have touched upon, but let's see a little bit in more detail. So speed is, so Spark is 100 times faster. Again, because most it is in memory compared to this is the Spark map, sorry, the MapReduce, where it is more of reading and writing from the disk. It is Spark is written in Scala, which is it provide a hybrid kind of object-oriented and the functional programming. But in Hadoop, the program is written in the Java language. From the processing perspective, the data processing, it is suitable for batch, real-time, iterative, interactive, even the graph kind of an application, whereas MapReduce is primarily limited to the batch task. And also from the ease of use perspective, it is compact and easier than Hadoop, and also the caching mechanism. So we can cache the data in memory, and also we discussed that it is also possible in Spark to again write the data back to the disk, whereas the Hadoop does not support the caching of the data because it's primarily a batch processing kind of a system. Now, another kind of a systems we will encounter in this is called as a NoSQL kind of a system. Now, NoSQL does not mean that they are not using SQL, but the term generally means that these types of database system does not follow the relational model. So it does not really mean that not only SQL, but generally means that yes, these systems are not following the typical relational model where the data is structured in the form of a relation or tables, rows and columns, and different entities are represented by different tables with a linkage among them using the primary key and the foreign key. Now, they are not meant to be replaced by the RDBMS system, but there are types of system which allows availability, scalability, and performance of a large amount of data. And unlike the relational data, which is limited to the structured kind of data, here we can other types of data sets could also be. So NoSQL database can be defined as 4 types. One is a column store, the graph, or the key value store like Cassandra, or the document store like, let's say, the MongoDB. Now, the problem with your RDBMS system was that they are primarily meant for scaling up or vertical scaling, which means if you are running a such system and the number of users have increased, or there is a more demand of performance, then we add more RAM, more CPU, more hard disk for storage and etc. But again, there's a limitation of how much you can expand vertically. And also there was restriction of the having a schema in place, and the data that is coming has to fit into that schema. Whereas these NoSQL systems are meant to be highly available, scalable, because they follow the horizontal scaling or scale out, which means I can add more nodes as and when we require, depending on the workload. And most of these NoSQL system also supports the storage of your the spatial data. So, for example, in MongoDB, they also allow the storage of your spatial data. You can store it as a JSON or a CSV and other kind of formats are also available. Now, also briefly talking about other products, other such solutions that you can come across. Again, this is on the open source domain. So this is a one solution called GeoTrellis, which is based on your Spark, built in the Scala library, which allows you to work on the raster datasets. Similarly, there is also called as spatial Hadoop, which allows you to analyze large amount of spatial data with all the capabilities of your data types, spatial indices, spatial operation to be done on a cluster environment using the Hadoop infrastructure. One more tool that I will request you to have a look is something called as a RAS daemon or a raster data manager, which basically use the concept of a data multi-dimensional data to be organized. So our satellite data could be organized here, and then it provide those slicing, dicing kind of operation. And also important thing is it also provides us a query language that we call as a WCPS or a web coverage processing service, wherein our data, which we have organized in the form of a multi-dimension data set, could be extracted, as you can see from here, which is we are storing the spatial temporal data, let's say 4 bands, and then we can retrieve those bands based on the bounding box and whatever operation that we want to do, we can do it. So these kind of systems can also help you in organizing your data and also processing your data, and then they can serve as a backend to your data processing or a data support system kind of application that you are building that could be user facing or could be restricted to the few users that you want to run on a larger kind of an area or a data source. Now, also talking here about the cloud computing. Now, big data and cloud are somewhere related. Maybe in the next slide, you'll be able to appreciate what I'm trying to say here. But first, let's try to understand what we mean by cloud computing. Primarily, it is like a utility as a service kind of model where people only pay for the kind of usage they are doing instead of having a first-hand investment in the cost for related to, let's say, network storage and application and so on. So there are various definitions, but one that generally is used is from the NIST. It is called as a model. So define cloud computing as a model which enable ubiquitous, convenient. So remember the keywords here is convenient on-demand network access from the shared pool of configurable resources. So those resources could be your network, storage, application, and services. Important thing is that can be rapidly provisioned and released with minimal management or effort or from the service provider interaction, which means the user should be able to do it from his own end. Now, if you look at the characteristics of this cloud computing, so these are the characteristics. First is the on-demand self-service, which means using this cloud platform, one will be able to provision a new virtual machine or set up a new kind of a cluster, all pure on a on demand as in when he's required. So if you want to add more nodes, you can do that without requiring the service provider interaction to do. Similarly, second characteristic is a broad network access. So you can access on various devices that could be from mobile to internet and other things. Now, third characteristic is resource pooling. So we can see the cloud platform as a kind of a pool of resources that are available. So based on the demand from the users, that could be utilized and then given to the end customer for serving the needs. And another way of looking at the cloud model is that it provides a rapid elasticity. Now, compared to your traditional on-premises kind of infrastructure, where first the hardware has to be procured and maybe installed, integrated into the existing system before you can carry on the elasticity. Or you want to carry, you can expand your existing system. But here, depending on the node and available resources from the resource pool perspective, the new kind of a node or the even the virtual machine resources could be increased at the runtime depending on our requirement. Node, which is very important, is a measured service. So one can measure how much time he's spending, what kind of usages could all be monitored through a kind of a interface these cloud providers provide. So this cloud model provide a very good let's say the business model, and also from the user's perspective, an environment wherein they can quickly provision the different services like hardware and also different kind of resources could be configured instead of having on premises kind of interface of infrastructure where they need to put a lot of cost factor. And also not to forget that such system has to be maintained over a period of time. So if you follow the cloud model, so somebody is taking care of that infrastructure for us, and we are only paying for the amount of usage of that. Because on an on-premise system, so the security, the availability, the power management, making sure the systems are running 24/7, the updations, the patching work, all has to be done by the individual level. So this we can use as a to outsource and by using the services of the cloud provider. Now again, there are various service models that are available. So can be prominently defined as three, which is IaaS, PaaS, and SaaS. So IaaS stands for infrastructure as a service, PaaS stands for platform as a service, and SaaS stands for software as a service. Now to understand these terminologies, we'll see the figure on the right hand side here. Now the first, this figure talks about if you have to maintain the complete application on your own, then let's say on-premise thing, then you have to make sure that you are managing the network, storage, the processes along with the operating systems and the runtime environment on the top where the application sits, which is your data and the software. So this whole is being managed by the individual if you talk about from the on-premise environment. Now from the infrastructure as service, as the term suggests, here we are making use of the infrastructure that is provided by the cloud provider. So the cloud provider or the vendor manages the network, storage, and processes on our part, and we are, let's say, procuring those services on demand from the service provider. So we are getting a, let's say, a bare metal or a, let's say, a virtual machine by logging into that IaaS provider. So we have a machine that is available to us from the cloud provider that we can remotely access, which is as good as having a physical machine at your premises. So now on the top, you can install the operating system library and whatever software and application that you want to build, you can do that. So first model is the infrastructure, where the service we are depending on the cloud to provide us the underlying infrastructure. The second is we call as the platform as a service. Here, and look at the figure here. Here, the vendor is taking care of both the operating system, runtime, along with the network storage and processes kind of resources. And we are only looking into, so our task is to only take that kind of infrastructure and only deploy our application or software and data sets that we want to host. So that is like a platform for which we can host our or maybe make live our application. The third is like a software as a service, which is mostly like, let's say, the email or a kind of a service, or let's say some other product like Salesforce kind of an application that you can access, or let's say ArcGIS Online that you can purely access. So this is like a subscription-based service. So again, if you see the complete the software part, the runtime operating system, and all the infrastructure is maintained by the vendor. We are only as a users who are trying to access the service. And since it is a broad network access, we can access on various devices like mobile apps and the let's say the desktops and the laptops. But important here, it is we are taking the using the capabilities of the cloud provider to access only the service. So that service could be, as I said, like ArcGIS Online to get all your GIS kind of service, or let's say email service that you are used to. So these are the three kinds of models that are a service model when we talk about from the cloud computing. Now, big data and cloud, they are related to each other. So, because when you talk about big data, we need to store, process, and analyze a large amount of data. And then individuals or the organizations are primarily adopting this cloud model. Because, as I said, it is very difficult to put that kind of infrastructure investment first in place, and also not only the infrastructure cost, but maintenance and other activities that has to be carried out. So cloud computing provides the organization as well as the individuals the underlying platform or the engine wherein this distributed processing can be done. So the big data can utilize such infrastructures rather than storing the data and processing data locally. So as we said, that the important characteristic is that it enables the users to use it like a utility, just like we use electricity or water kind of thing. So pay only for the amount of time the user is used, and also on-demand access, so scalability can also be done. Now, in this slide, I just want to tell about the framework that people can build using the cloud along with the big data. So as you see on the bottom here is that cloud computing is provided your infrastructure for processing the big data. So here you can see the characteristics of big data we talk about, which is volume, velocity, variety, and veracity. And the data is coming from various sources, which we have discussed, from IoT to social media to GPS, other location-based services data, the GIS data sets, the remote sensing, and also the data sets coming from the smartphone. Now, from this cloud infrastructure, which provides on-demand self-service, the major service, broad network access, rapid elasticity, and resource pooling, the characteristic we can use it for hosting various this big data frameworks like HDFS, MongoDB, RASDMN, Spark, and etc. And on the top, we can build various applications. So it could be for purely for archival and management. It could also be for powering your application to provide them access. It could also be for data analytics. It could also be for the simulations. Now, from the user's perspective, once this infrastructure is built on the cloud platform with the linkage of the big data frameworks, various geospatial domains of the usage could be addressed. So it can be from the domain of urban planning to understanding climate change to land use, land cover change, or maybe taking some project under smart cities or monitoring the environment and other things. And again, the output of them can again be used where the fifth, we talk about the value, and then maybe you can use it for the decision support and also for the publication. The reproducible results could also be put forward. So the cloud and this big data are quite of related, and this cloud provides the underlying infrastructure and also elevates or removes the burden on the individuals to manage that infrastructure on its own. One very good example of this is a Google Earth engine, wherein it provides necessary, all the data sets are readily available. So various data sets that I mentioned here, like Landsat, Sentinel, MODIS, the various kind of products from terrain, let's say land cover, some atmospheric data sets are all available, and it is rapidly daily it is growing. To not only provide the platform where the data is available, but also provide an environment of scripting, or the code editors are also available where the people can also write the code by making use of the APIs or libraries that they are providing. Now, please remember that this is different from the traditional mechanism where we used to first download the data, then pre-process the data before we can use it for analyzing. So here the data sets are readily available, ready to use format, and the data and the, let's say, where the data reside, the processing is happening at the that location, and instead of migrating the data to your locally, downloading and then processing it. So that way, and since it's working on a cluster environment, it's very fast. So it provides the satellite imagery along with other products that you can access for more than 40 years. And it also provides an API, so you can write your programs using JavaScript, and you can also use it for writing using the Python, and you can also publish them as apps also. That provision is there. Using this, many people have created various kinds of applications, but classic example is this time lapse, which will come across if you visit this Google Earth Engine site. So people are using, so they have created a various time-lapse kind of animation. So for understanding the glacier retreat, how to see the urban growth, even the deforestation. So we need to gather and analyze a large amount of data. So these kind of platforms makes really easier for people to carry out such kind of studies. Because remember that here we are working around a huge, humongous amount of data sets that has to be processed and stored before we can use it for analysis. So in this session, I talk about an overview of the big data, where we started with seeing how the data has evolved over a period of time, what contributes to the data deluge era, and then we have discussed the definition of the big data and what were the limitation of the traditional processing mechanism. And followed by, we have also seen the various frameworks that are available from the geospatial domain. And then we also discuss what are the various data sources that are contributing to big data under the geospatial domain. I'll give you a glimpse of the few tools that are available under the open source. And then finally, I've also discussed the concept of the cloud computing and how it is related to the big data. So with this, I will stop here and wait for your questions.